Good morning, everybody. Did you enjoy the party? Did you like the party? Was it good? First of all, thank you so much for coming here, even though you were at the party yesterday, and for dragging yourselves out of bed. Thank you very much. This deserves your own applause here. This is really good. I know it's tough. Welcome to the last day of reInvent, and we hope that we have some very good content for you prepared that makes it worthwhile having dragged yourselves out of bed. Welcome to the Running Lean Architecture session. And my name is Konstantin Gonzalez. I'm a solutions architect with the Amazon Web Services Germany team. And this is Markus Ostertag from our customer Team Internet. So this is actually the third time we are presenting this talk at reInvent. So who was here last year for the same talk? Okay. Don't worry, we brought some new content for you. So why are you here? So first of all, my goal here is to help you lower your AWS bill. And actually, I want to make it really specific. I want you to save at least as much money as you will need to come to next year's reInvent, including flight, hotel, ticket, whatever. And I'm pretty confident that we can do that. So there are so many ways to save money. We're going to discuss all of them. And even if you choose just one or two, it'll be enough to save for your next year's reInvent ticket. But we'll also discuss some things that you can do to make your architecture more scalable, more robust, and more dynamic, which is also a good thing, right? And you'll also gain some more time to innovate so that you can create new solutions, new stuff for your customers, instead of worrying about infrastructure and other things. We're going to check out some real-world customer examples, and a lot of these things are pretty easy to implement. So let's get started. Actually, if you want to be really lazy, you can get away with doing nothing. And the reason is that AWS, as a company, is built on reducing prices. And why? Well, whenever we reduce prices, we see more customers joining our platform, right? And when we see more customers, we see more AWS usage, which means that we get to build more infrastructure, which in turn means that we can enjoy better economies of scale. Quite frankly, the more people use AWS, the lower our prices get, the better we can negotiate better prices for IT equipment for you. And that means that we get to enjoy lower infrastructure costs, and that in turn helps us reduce prices. And we always choose, since we are a retailer, to always reinvest whatever we can save into our customers by lowering prices. And there are two things that accelerate this virtuous cycle. One of them is the more people use AWS, the bigger the ecosystem becomes, the more partners come on board, the more solutions become available, the more features we can create, and new services that we can create out of that. And the other thing is, it's not just about getting better deals with your suppliers, because the bigger our infrastructure gets, the bigger the problems become that we can tackle. We can now start looking at things like more optimized power supply for whole buildings and data centers. We can start engineering bigger components that help us save even more money and be more efficient, which again helps us reduce prices. And since 2006, we were able to reduce our prices 50 times. And of course, we plan to continue doing so. Well, you can also get away with doing almost nothing. And that means that if you have booked AWS Business or Enterprise support, you get access to the AWS Trusted Advisor tool. And Trusted Advisor is an expert system. It's a completely automated system that will scan your infrastructure and point out improvement opportunities for you. Improvements in security, in availability, and even in cost optimization. So AWS Trusted Advisor can deliver to you a weekly report pointing out the pieces of your architecture where you can save money. And we have many customers that just by buying business support and using the AWS Trusted Advisor service, we're able to recoup back the whole costs for business support. So essentially, you can get business support for free by just listening to the AWS Trusted Advisor recommendations. And another thing is important here. In the old world of IT, when you build something, you spend a lot of time planning and negotiating and putting together some sort of architecture blueprint. And then you build something, and then eventually, after a few months, you run it. And then your architecture is pretty much set in stone. There are not many things you can optimize, at least not cost, because if you end up buying more equipment to optimize something, you actually have to pay more. In the cloud world, this thing becomes a cycle. You can architect a solution, you can start small, you can build something, and then you can monitor, and then you can identify what are the next improvement opportunities, and you can re-architect, change your architecture, tweak it, and become more efficient over time. So I would encourage you to see cost optimization as a cycle. And such a cycle can happen in minutes or hours or days, at whatever pace that you want. So I know you're here to learn some more specific ways to re-architect and improve your cost. So let's take a look at some 7 steps you can take, 7 specific things you can do to architect for lower cost. And if there's one thing I want you to take away is the best way, the easiest way to save cost is by turning off unused instances. It sounds pretty basic, right? But you wouldn't believe how many customers I see who are still running AWS instances 24/7, even though they don't have to. And there are so many opportunities. You can look at your developer and test and training instances. You only need them during the working hours of weekdays. You don't need them at night. You don't need them over the weekends. You can just switch them off over the weekend. And since we are completely based on a pay-per-use model, whenever you switch off an instance, you stop paying for it. You can just start with simple instance start and stop in the console, or you can tear up and build up whole architectures at the press of a button using automation techniques such as AWS CloudFormation. So think of AWS instances as disposable units of compute that you can throw away when you don't need them and then save money. Here's an example of a customer. It's a large software company, and you can see in this graph what their instance usage is over different types of instances. And when they do it right, consequently, they always switch off unused instances for testing and development and for training. And you can see how the weekdays become visible in this graph as they turn off their instance overnight. You can see the weekends where the graph goes down, and you can even see some holiday patterns in this graph as you notice how dynamic their use of AWS EC2 is. And in this particular case, this customer has saved 35% of their EC2 bill just by thinking smart about when they need their instances and shutting them down when they are not used anymore. So, of course, you can be a little bit more dynamic here, a little bit more sophisticated by automating your setup, right? And there are many ways to automate your AWS setup. You can use the AWS software development kits. You can use the AWS command line interface. So who has used the command line interface before? Okay, I'm a big fan. There are great sessions on re:Invent about how to optimize the use of command line interface. So you can set up simple scripts that do the start and stop of unused instances thing for you. You can use CloudFormation to start and stop whole architectures and whole data centers at the same time, or OpsWorks. And there are some third-party tools by our customers and our partners who can help you be more automatic and be more dynamic, such as the Netflix Janitor Monkey, which will automatically scan your infrastructure for instances that are not really nicely tagged, or will automatically shut down certain instances based on your rules. Or you can use the Cloudlytics EC2 scheduler, which is kind of like a cron for switching on and off instances. There are many ways to automate. And I'd like to point out one specific way, which is autoscaling. So autoscaling is an AWS feature that you probably know. Who uses autoscaling already? This is great. Last year, it was just a third of the room, and now it's more than half of the room. This is great. So I see that this talk is working. So autoscaling works like this. You set up your autoscaling group of instances. Maybe they are web servers or application servers, and you attach them to Amazon CloudWatch metrics, which measure the load on your instances, or you can attach them to a scheduled to an event scheduler. And over time, as your instances are being used more and more, the CloudWatch will send an alarm to the autoscaling group, telling the autoscaling group that you need more capacity. And then autoscaling will automatically launch a new instance, attach it to your group and your load balancer, and your instance number grows with demand. And the whole system works also backwards, because if your instances are not being used anymore that much, this autoscaling system will automatically shut down unused instances for you, and then you will go back to a smaller instance use. So this is a very simple system. It's simple to set up. You can bring down everything into code. This is an example in CloudFormation on how to set up a launch configuration that contains everything autoscaling needs to know before starting a new instance. And this is how you set up the actual autoscaling group with the availability zones you want to be spread across, and with some other parameters such as the minimum and maximum size for your autoscaling group. So essentially what autoscaling does, it helps you align resources with demand. And it makes sure that you only spend the necessary amount of money because you only start just the necessary amount of EC2 instances for your job. Well, some people at this point say, yeah, I get this autoscaling thing, but I have so many applications, they are so small, I always only need one instance, no matter how much load I have. And then I have these other small batch jobs and whatever here, and I always end up using just one instance for my stuff. How can I optimize here? And this is where some new stuff comes in that we launched last year. You can use Amazon EC2 Container Service to consolidate small workloads into a lower amount of instances. So just as a quick recap, the EC2 Container Service, or Amazon ECS, is a service that helps you easily manage Docker containers. It provides for some flexible container placement. It's designed to be used with other AWS services, and it is extensible, it's easy to use, and it helps you manage Docker containers. And the way you can save money with this is by simply looking at all your very small applications that may be running each on their own individual server, and then start consolidating them down into Docker containers that can run on a smaller amount of servers. Because essentially in this case, we use the Docker feature that enables you to sort of pretend that you're running inside a machine, even though it's just a container. And that means that you can isolate your small jobs from each other, so that enables you to run multiple applications on the same AWS instances. So this simple example here shows how you can consolidate down from 6 instances to 2 by wrapping everything into Docker containers. So take a look at Amazon ECS if you haven't already, and try to consolidate your smaller applications into Docker containers. Now there's an even smaller way to run containers, and that is AWS Lambda. So here's a very quick example on how Lambda works. In this case, we have an Amazon S3 bucket, and if you drop in a new image into this bucket, you can set it up to trigger a Lambda function. The Lambda function is where your actual application runs. It's not running in a container anymore. It's just a piece of code that you give AWS Lambda that will be executed when an event happens. In this case, it was a picture event, and then it'll do the picture compression automatically, and then it will shut itself down. And I'd like to borrow a phrase from Werner's keynote yesterday, because there is no cheaper servers than no servers. And actually, AWS Lambda enables you to set up a completely serverless architecture, because it takes automatically care of scaling, it takes care of provisioning. You don't need to manage any infrastructure, you just bring your own code, and you get 1 million requests for only 20 cents. So 1 million triggers, 1 million executions of your Lambda function for 20 cents, and the first 1 million are free. So the granularity is also another important thing. With EC2, the granularity is an hour, and with Lambda, we bill you only at 100 millisecond granularity for executing your code. So this is a great way of not paying for idle time by just porting your applications into a set of Lambda functions. And the Lambda team told us that if you see 40% or less utilization on your existing EC2 servers, that's a great opportunity to save money with Lambda, because then you can set up a Lambda architecture that is dynamic and that does the same thing at a lower cost. Quick question? There are different classes of memory with different classes of pricing, and this price is the beginning price for the smallest Lambda function memory. So try to think about AWS Lambda and how you can port your application to it. Now the number 3 thing you can do, and this is a bit more on the billing side, is you can use reserved instances. So how does reserved instances mean? Well, the normal pricing scheme is a fully pay-per-use price. You just use EC2 and you pay per hour, and that's it. But if you know upfront how much usage you're expecting, you can pay upfront and therefore save a lot of money, because reserved instances work like this. You reserve a certain amount of capacity, you pay them up front, and then you enjoy a very, very low, a much lower on-demand price for that instance. And in this graph, you can see how this can play out over time. The blue line is your regular on-demand pricing. You can see in the red line, which is a 1-year reserved instance line, that in the first month, you get billed the reservation fee, which is, of course, a bit more than the hourly fee. But then over time, it levels itself out as the low hourly price kicks in, and then you will end up paying a lot less after 1 year or after 2 years. I would recommend to only buy 1-year reserved instances, actually, because since we like to lower prices all the time, you definitely want to be there when we lower our price and then buy the next reserved instance. 3-year reserved instances have their reason for existing, but this is more like for billing reasons if you have some accounting policies that are like stretching to 3 years. So for practical reasons, I would say 1-year reserved instances are the sweet spot. And as you can see, the break even for buying a reserved instance can happen as early as after 5 months. Reserved instances are flexible. You can move them between availability zones. You can move them between platforms. You can modify them. So you can really reuse them if you happen to change your architecture after having bought some reserved instances. And there are some tools that help you track your savings over time, so you can verify that your purchase was a good decision, and that can help you analyze your instance usage so that you can identify where the next best purchase should come from. So with that, I'd like to hand it over to Markus, because Markus at Team Internet, he has a pretty good understanding on how to leverage reserved instances for saving money. So here's Markus.
Yeah, thanks, Konstantin. Actually, a little bit about who is Team Internet. I'm the head of development at Team Internet, and we're one of the leading companies in the domain monetization business. So everything around domain parking, domain registration, those kind of stuff. We are actually only 20 people, so a fairly small company, and our headquarters is in Munich, Germany. And we're a very, very tech-focused company. That's why we can be so small, because we're always trying to scale within tech and not with people. We have 2 main projects. One of the projects is parkingcrew.com, which is one of the leading parking platforms of the world. And the other one, which is a project I want to talk about a little bit more today, is DNTX. DNTX is 100% inside of AWS. And DNTX is kind of a real-time bidding marketplace for domain traffic. So what we are actually doing is if a user enters a domain in this URL bar, which is parked with a parking company, we get a call from this parking company that there is a user right now. We're trying to find out some kind of related information, targeting information for our advertiser base. Our advertiser base has more than 10,000 advertisers with more than 250,000 campaigns right now. And we're trying to find the highest bidder for this specific user the parking platform is asking us for. So we're trying to find out, okay, we're able to pay around 5 US cents, for example, for this user, and then we deliver back this specific bid to the parking platform. The parking platform then redirects the user to our tracking platform, and we redirect the user directly to the landing page of the advertiser. The whole process I just explained needs to take place within 200 to 300 milliseconds. So we're talking about a very, very fast process, and actually right now we're seeing up to 15,000 requests per second from parking platforms. So we're also talking about a really huge volume. So like Konstantin just said, we're making a very heavy usage of reserved instance. And what you can see here is the green part of the bars are actually our instance hours, which are backed by reserved instances. And the gray part of the bars are our on-demand usage. So we're always trying, our goal is actually to get 100% instance hours backed by reserved instances. So because obviously we can save 50 to 60%. What we're trying to do is we have one rule of thumb in our company, which fits for our use case at least, but maybe that's something you can adapt in your company too. If an instance that runs for 24/7 for more than 2 weeks and can't be stopped right now, so in this very moment, we buy reserved instance for this instance. So the idea behind this is we know from our use case that if there is an instance which does a job which seems to be production related, so we can't stop it in this very moment, then we will use it for at least the next 3 or 4 months. So that's our experience in our use case. And like Konstantin just mentioned, the 1-year reserved instances are very, very good. We only buy 1-year reserved instances. And so this is kind of our thing, how we do it. To find out actually what kind of instances are right now running on demand, you can use the EC2 instance usage report inside of your EC2 console and just select the filter on purchase options and select the on demand only. And then you get something like this. This.
Oh, wait a minute. Just go back.
Okay.
Yeah.
This one. Yeah. I also group by instance type here. So what you see here is that we're running several T2 mediums. Those are the green bars. We already bought reserved instances for those. We had one instance, the purple part of the bars, which we stopped in this very moment as it was not production relevant. And we started several others. So this is a good way to find out what I'm running right now and what need to be backed by reserved instances. And like I just said, we're always trying to have the goal that we're nearly 100% on reserved instances. And especially even if you think about, okay, I buy these reserved instances for 1 year, there's still always a baseline you run all the time. And like Konstantin already mentioned, you can change availability zones. You may even change sizes of instances, those kind of stuff. And so it's a very, very easy way to save money. And we save around 50 to 60% only with reserved instances, like I just said. Yeah, and back to Konstantin.
Thank you, Markus. So as you can see with Markus' example, you can actually save 50% of your EC2 usage just by using reserved instances. And that should be probably enough for most in this room to pay for their next ticket to reinvent. But we have some more stuff for you. So one of my favorite things is actually spot instances. Who uses spot instances already? Not a lot of people. Great. So now there's an opportunity for you to save some cost. So spot instances are pretty funny because, as you can imagine, at AWS, we operate a lot of hardware. We have lots of data centers, lots of hardware, and we have to buy a lot of hardware and run it because we never know how many customers are going to use our platform. So that means if you look at our hardware utilization, we have to keep a headroom of unused instances because we always have to be ready for the next instance that the customer wants to launch. So that means that we end up doing the same as some energy companies do. We just resell our headroom on the market, and we call this spot instances. And the way they work is they are completely based on supply and demand. So that means that you as a customer, you can tell us, hey, dear AWS, I'm OK paying 10 cents for this X1 instance that you just launched, and because I don't want to pay more than that, right? And if we have an overcapacity of that instances, because of course we need to keep some headroom, and if you are among the bidders who bid the right amount of money, you'll get access to that large instance for just 10 cents. Because this is a completely open market. You have a lot of bidders on one side bidding whatever price they want to pay. And then we have the supply on the other side of our headroom capacity that we match through our spot instance engine. So we match demand with supply, and then you can just use our overcapacity instances. So by now you will probably ask, so what's the drawback? So what's the downside here? The downside is that, of course, the headroom is there to satisfy demand once any other customer wants to use them at a regular price. So when our supply goes down, we have to claim those instances back. So that means that with spot instances, you need to be prepared that the instance is going to be terminated as soon as the current spot price crosses your chosen maximum bid price. But the good news is you only pay for the current spot price, that is the current price. You don't pay your maximum price. You only pay the current spot price, which is very dynamic. And since we just talked about autoscaling is also a great way to make your architecture robust because it will automatically refill your pool with new instances as they are terminated. So you can actually mitigate the risk of having your spot instances being terminated because of pricing events. So here's an example on how the pricing looks like. In this case, the regular price for on-demand for this instance type in this availability zone, because the prices change per availability zone. They are really based on the locally available pools of instances. So the regular price in this example here is 24 cents by instance hour. And the current spot price is about 10% or 11.7% of that price. So that means you can save up to 90% of EC2 instance cost by taking advantage of spot pricing. But you can also see that the spot pricing can be very dynamic. It can be even bigger than the on-demand price. And why is that so? Well, some customers say, I don't care, I want to keep my instances. I know that over time, the average price will always be much lower than on-demand. I'm fine paying a lot more just for a few hours because over time, the price is going to play out itself, the average price. That's fine for some customers. Other customers are a bit more cautious. They will only submit very small bits and be very careful and be very dynamic here. You can choose how you want to play those spot instances. But the point here is, if you are smart about instance use, if you can automate your system enough so that you automatically restart instances that are terminated out of the spot pool and maybe replace them with on-demand instances, then you can really save a lot of money. So here are some use cases that work really well with spot instances. You can use them for stateless web and application server fleets. They are a great addition to your Amazon Elastic MapReduce cluster because Elastic MapReduce is inherently tolerant of instance termination. And that means you can set up your Elastic MapReduce cluster with a set of core instances that you will always keep. And you can use on-demand and reserved instance pricing for them. And then just add spot instances to your Hadoop cluster. And yet the more instances you add out of the spot pool, the faster your cluster is going to be done, and the more money you will save, because you will also save for the on-demand part, because you will be done earlier. So this is a great way to save with Amazon Elastic MapReduce. You can use them for continuous integration fleet, high-performance computing, grid computing. These are all use cases we see customers using with spot instances. There's a great webinar explaining all of the spot intricacies on our webpage, amazon.com/ec2/spot. And I would encourage you to check this out in more detail. There's a new tool called Spot Bid Advisor, where you can type in your favorite region, instance type, and the kind of pricing you want to bid. And it will tell you the probability that you can keep your instance through a long period of time. And it's actually a very new feature that we launched just a few days ago. And frankly, I didn't have the time to create a new slide for that. But that new feature is called Spot Blocks. You can actually tell the Spot engine, dear Spot engine, I want an instance of this type. I want to use it for 3 hours. And then I don't care if it's terminated. But I want to get those 3 hours. And then the Spot Block feature will allocate the instance for just those 3 hours for you. And you still get to enjoy spot instance price savings. So if you know upfront that you only need an instance for a couple of hours, you can use the new Spot Blocks feature to allocate them and save some money there. So a quick recap, this is very dynamic pricing. This is a bit sophisticated, but if you're smart about using spot instances, you can save 80 to 90% of EC2 cost. And then check out different prices. They vary by availability zone, they vary by region and by instance type. And you can leverage auto-scaling. You can set up actually 2 auto-scaling groups, one with spot instances that saves you a lot of money, and the other one with on-demand that will compensate for any spot instances that get terminated, so you get the best of both worlds. And then there's another new feature called Spot Fleets. You can manage thousands of spot instances with a single API call and use them to seriously save money on large fleets of web servers. Okay, we talked a lot about EC2 and compute. Let's talk about storage now. As you know, Amazon S3 is the golden standard of cloud storage at AWS. It is designed for 11 nines of durability, and it delivers 4 nines of availability for the service, and you can even enjoy a service level agreement for that. It gives you unlimited storage with high throughput, and it's really easy to use. And the standard pricing starts at 3 cents per gigabyte and per month. And one good thing is you get automatic discounts. I get to meet a lot of very large customers. And large enterprise customers, the first thing they say, hey, I am this really important company. Can you give me a discount? And the answer is, yes, you get the same discount as everybody, and it's on our price list. And it is automatic. The more you use, the less you pay. So that's great. But you can save even more, because we recently launched a new storage class, which is called Standard Infrequent Access. This storage class is designed for use cases where you want to save a lot of data, and you don't necessarily want to read it back all the time. And that would be like the classic case in backups or archives, because with backups or archives, you save them, and then you hope you don't need them anymore. But still, you don't want to pay the full price, right? So in the new Standard Infrequent Access class, we basically save on the retrieval part of the S3 fleet. So that means that you get a slightly lower availability, 99.9%, but the pricing drops down to 1.25 cents per gigabyte of storage, which is a 58% savings on your S3 storage cost. There are some small strings attached. Objects have to be kept for a minimum of 30 days, and we bill a minimum of 128K per object, and there is a small retrieval cost. But again, this is designed for use cases where you save a lot, but you don't necessarily want to read back a lot of data. And so this is perfect for any kind of backup and archiving scenario. And then you can leverage Amazon S3 lifecycle rules, which will automatically transfer objects in S3 into the lower priced infrequent access class after a certain amount of time. So you can save your backups to S3 regular, and after a month set up a rule that anything that is older than a month will automatically be transferred into the infrequent access class here. And then there is our favorite class, which is called the Amazon Glacier storage class, which has been there for a couple of years now. And this is our latest price reduction, actually. So we reduced our prices on the Glacier storage class. So now the Glacier storage class presents you with 77% savings over the standard storage, but it is a bit colder than the infrequent access class. It means if you want to get your data back, you have to wait 3 to 5 hours for the retrieval job to bring your data back. But you get an even lower price of 0.7 cents per gigabyte of storage. So this is great for really cold data. This is great for archiving data that you only want to dig up when the auditor comes in once every couple of years. Or this is great for your oldest backups. And again, you can leverage S3 lifecycle rules. You can, after 1 month, you put it into standard infrequent access, and then maybe after 3 months, you put it into the Glacier storage class because the probability that you will actually need it is way, way down, and then the pricing starts to play out for you. Click. Okay, maybe the battery is dying here. Don't save on batteries, save on AWS. So let's become a bit more sophisticated here, and I'm very glad to have one of the world's biggest DynamoDB experts here from our customer side here. Let's look at Amazon DynamoDB. Who uses Amazon DynamoDB in some way or other? Great, so now this is the piece where you get to enjoy a little more cool stuff here. So the way DynamoDB is priced, it's around capacity units. You have to allocate capacity units for read and write capacity, and this is your opportunity to optimize your cost here, because you can optimize the usage of capacity units. But of course, there is always a trade-off to make. You need to provision enough capacity units so your application runs and doesn't see any out-of-capacity errors, but you don't want to provision too many capacity units, because then you will end up paying more than necessary. So here are some ways to optimize on DynamoDB. First of all, you can use caching and save read capacity units by caching your stuff on the application side or using some other caching things. And we have a whole section on caching coming up in a couple of minutes. But the other thing is you can become smarter at allocating your tables and capacity units. And there are some great ideas there in the DynamoDB documentation. You can, for instance, use multiple tables for different access patterns and then provision capacity units individually for those tables. You can look at your time series data and try to map time chunks into its own tables, and as you don't need them, you can just delete whole tables, because deleting single objects in DynamoDB, that eats up on your write capacity units. But if you delete a whole table, that's a free operation. So if you're piling up time-based data and then you offload them into some other storage such as S3, by having 1 table per day or 1 table per hour or 1 table per month, whatever, you can kill the whole table for free without paying for the cost of deleting items in the DynamoDB table initially. And then, of course, you can use compression to save some more on capacity units. There's a neat trick that our customer Shazam came up with. If you do encounter an out-of-capacity error in DynamoDB because you were really cheap on provisioning write capacity units, you can offload, you can buffer your write request into an SQS queue. And then you can have a process in the background that reads back those write requests from SQS and retries them on the DynamoDB table at a later time when capacity becomes available. So by using this trick, by using SQS essentially as a write buffer into DynamoDB, you can provision just the average amount of capacity unit usage. You don't have to provision for maximum capacity, and that means that you can save some money with capacity units on DynamoDB. There is a tool called Dynamic DynamoDB, which is on GitHub. So you just Google Dynamic DynamoDB, and then you can download this tool. This is a simple Python script that helps you automatically figure out the right amount of capacity units. So it will automatically adjust the capacity units for your tables based on the historic use and based on some rules that you can give it. And we recently upgraded the CloudWatch metrics for DynamoDB to be at only 1 minute granularity, which made this tool even more useful because it can now react in very near to the time to your usage. So think of this as auto-scaling for DynamoDB, which really makes it easy for you to be optimal, to figure out the optimal capacity unit usage. Okay, now I'd like to hand it over to Markus because he found out a really neat trick on how to save capacity units on DynamoDB.
Yeah, thanks, Konstantin. Yeah, to explain a little bit what we did in this tweak, actually, is I need to explain what we're doing with DynamoDB. We're talking about a tracking database, actually. So everything which happens during our bidding, every view, every click, every kind of event, we're adding rows to a DynamoDB table. Just like Konstantin mentioned, we have several tables, one per day, and then we add to this specific day table. Those rows have a size of around 1.5 to 2.5 kilobytes. And what we did was we just inserted it to the table, used a global secondary index. We used the projection all, so we copied over the whole row. And then we queried on the global secondary index and exported the data out of DynamoDB to transform and work with it. So the point now is what internally happens is that if we insert to a table, DynamoDB copies over the whole row due to the projection all to this global secondary index, which is actually, it is another table. So you provision your own throughput on this global secondary index separately from the table itself. So then we had the system. It worked, actually, but it costed really a lot of money on the global secondary index. And so we looked at, actually, the pricing of DynamoDB again. And then we saw, writes are calculated in 1 kilobytes per chunk. So every time we write one row, which, like I said, was 1.5 to 2.5 kilobyte, we not paid one write, we paid 2 or 3 writes. But the reads can be of a size up to 4 kilobyte. So then we thought, okay, the global secondary index is a really, really important part, and it costs a lot of money. So why not change the projection for the global secondary index to keys only? So what DynamoDB now does is that it not copies over the whole row, which was 1.5 to 2.5 kilobytes, but it copies over only the key of the table and the key of the global secondary index. So we have now rows which are in the global secondary index which are smaller than 1 kilobyte. So we save 1 to 2 writes for the copying over. As we already had a process which worked on the global secondary index, this process now, of course, not gets the whole row. But that isn't really a big deal because we get the key for the table out of it, and so we can read with this key directly from the table itself. So we have more reads here, but much lesser writes. And the most important point here is writes are more expensive than reads. So this very little tweak without real big issue on developing those things saves us multiple $1,000s a month with our throughput. And so yeah, as I told my boss, okay, we will build this and we'll save several $1,000s. He said, yeah, okay, you can go gambling at reInvent, so that's fine.
So Markus already saved like 10 years worth of reInvent trips just by being smart with EC2 and reserved instances. And now, Markus, with what you saved here on DynamoDB, you can actually buy some new LED panels for Z in this set, right? So cool.
Yeah, that would be nice. Maybe they work then.
Yeah, so let's look at some more ways. The other thing you can do is, so after being smart about your DynamoDB usage, you can also be smart about, do you really need that much infrastructure? Do you really need a lot of backend stuff running on AWS? Or are there ways to offload part of the work there to somebody else at a cheaper cost? So let's take a look at 3 ways you can offload your architecture, because the less you need your architecture, the less you have to pay for it. So 3 ways are: you can introduce caching into your architecture, you can use Amazon CloudFront to cache whatever is happening on the web tier of your architecture, and you can also use any existing Amazon Web Service instead of building stuff from scratch. For instance, let's take a look at that example a bit later. But let's start with caching here, because that is really a very neat way to save money. So, Markus, what do you do with caching? Because that's, now pay attention, this is really good.
Oh. Yeah, actually, when we build up DNTX, we just build it up. So, like, trying to be as fast as possible, time to market, you all know the drill. So we had some backend servers which are talking to our databases. We're using right now MongoDB, DynamoDB, and Amazon RDS. So when we built the system, it was ready, it worked, everything was great. But then it was like, yeah, it's very expensive. So let's try with caching. AWS solution architect said, yeah, use caching, everything is good. OK, so we did. We implemented an Elasticache Redis node between our backend servers and our databases. Very easy caching. So every time we ask our database, we now ask the Elasticache Redis, is there already some kind of information for the specific query in it? If not, we still ask our database and save back the result to the Elasticache Redis. So for the next time with the same query, the cache can answer now. So we will reduce, hopefully, our database load. So this is the graph where you can see 2 deployments of different caches for our MongoDB. The 2 arrows, actually. And we were able to shut down 8 of our MongoDB machines. Sounds not like a big deal, but if you think about our MongoDB machines costs around $500 per month, and this one Elasticache Redis node, which does all the caching in our system, costs only $300 a month. So we're talking about savings around $3,700. The very same Elasticache Redis node was then implemented with DynamoDB. So what you see here, I put an arrow on it, but I think it's pretty obvious where we deployed the cache. We saved, for this table, you can see the graph here, 3,000 reads per second. Then we implemented it for all our DynamoDB tables, and now we're able to save more than 20,000 reads per second, which, again, multiple $1,000s per month. I should really do the gambling, right? But even after we implemented the caching, it was like, yeah, that's cool. We have caching now. But we make a very, very stupid mistake, actually. We forgot about negative caching. And when I say negative caching, what I mean is our database answers sometimes with, I don't have a result. So result empty. We're working on JavaScript, and you know it's not type safe, so the usual developer would do something like, if result, then cache it to Redis. If not, everything is good. So the problem is if our database just don't have a result, we don't cache it. Now, if you think about what we are actually doing, we're asking our database, hey database, do you have a bit for this specific targeting options? And it's totally OK for our database to answer, no, I'm sorry, I don't have a bit for that. And actually, that's a very, very valuable information, because if we're now asking in the same second or after several seconds, the same question again, like with the same targeting options, database, do you have a bit now for this targeting options? The database again will say, no, I still don't have a kind of bit. So it's very, very important to save the empty result to the cache, because now, if we implement that, the cache can answer these questions, and we reduce our load on our databases. What you can see here in the graph is the dark part of the bars are our cache hits, so our cache can answer the question, and the light blue bars are the misses, so we need to ask our databases, actually. We had a cache hit ratio of around 25 to 30% without negative caching. This is it with negative caching. So we raised our cache hit ratio to 89 to 95%. So now we're talking about around 5 to 11% of all our queries we actually really need to ask our database. Everything else comes out of this very single Elasticache Redis node for $300 a month. So we're still talking, with this negative caching implemented, we again saved several $1,000s a month. Yeah.
Thank you.
Back to you, Konstantin.
OK, so you can also do another level of caching, which is CloudFront. And the important thing to remember about CloudFront is many people think of CloudFront as being just a cache for web data, and it's nice, and it accelerates stuff because stuff is local, cached on those nodes. But the good thing is that CloudFront can also be used for dynamic content. You can use CloudFront even without caching. So that means that you can even accelerate your application readiness, your application performance, just by putting CloudFront in front of it, even if it's a fully dynamic application that can't be cached, because CloudFront comes with a lot of optimizations on the networking side. It comes with some TCP optimizations that lower the latency of your request. So you can actually use CloudFront to accelerate your web application, and on top of it, you also get a fleet of proxy caching servers that can accelerate and cache your static content and whatever can be cached. Now, Markus has a neat way of using CloudFront in its dynamic mode.
Yeah, actually, like Konstantin just said, CloudFront is content delivery network. I think that's the very obvious thing everybody does with CloudFront right now. But we thought about, before we actually built DNTX, how should we architect the whole system? Like I said in the beginning, we need to be very, very fast with our answers. So we only have 200 to 300 milliseconds, that way around, to answer every question we get from the parking companies. So network latency is a huge issue for us. If you think about that, network latency can go up to 150 or even 200 milliseconds from, for example, Australia to the US East or something like that. It's very, very important for us that we trying to shave off as much as possible from this network latency. So we thought, OK, we need to do several regions. So typical multi-region setup. We need to be in our 3 important regions, which are US, EU, and Asian Pacific. But we would duplicate or multiply our whole infrastructure, because we need to be in every region. And then there is a database in each region. So we need to do some kind of multi-master syncing. Everybody who ever did multi-master syncing knows it's not fun, not at all. So then we came up with the idea, yeah, OK, the main point of network latency is from the end user to the entry point of the AWS net. And as CloudFront has several edge locations all over the world, more than they actually have regions or availability zones, it might work if we put CloudFront in front of our infrastructure and just let CloudFront do the job. So we don't cache anything on this CloudFront edge location. So we're working with a TTL of 0. So the advantage Konstantin just mentioned with, yeah, you get your content out to the cloud, to the edge locations and cache it there. We don't do that. We don't do any caching on the CloudFront edge locations. We just use CloudFront as entry point to the AWS net, which should be as near as possible for our end users. And so we built actually this system. This is our architecture. We're working with it right now. So we just use US East 1 as our main region, have only 1 infrastructure instead of 3, so savings of 66%, obvious. And we just put CloudFront in front of it. And as we have CloudFront now, we're talking not about 150 to 200 milliseconds. We only talk around 20 to 30 to the edge locations. And from the edge location to our own Elastic Load Balancer, AWS optimizes very, very much of the whole TCP IP handshaking process, everything around it. You don't need to take care of that. And so we have a total latency not from 200 milliseconds, but around 40 to 50 milliseconds from all over the world. So my tip here for you is use services not only for the obvious purposes, but also for some kind of sneaky tricks you can do with the things AWS just gives you. And so we use CloudFront. We're very happy with that and save a lot of money with it.
Thanks, Markus. So this conference is called reInvent. but it doesn't mean you should reinvent the wheel here, right? Because you're here to reinvent the way you do business with your customers. And what I want to say with this is try to leverage as many existing services as possible. Because if you, for instance, let's take the example of Amazon Cloud Search. We just launched AWS Elasticsearch Service, which makes it really easy for you to set up your own Elasticsearch cluster with Kibana and everything by the press of a button without having to launch instances, install software, and do all the administration stuff.
And that's awesome, actually. Elasticsearch is really awesome. You should use it.
Thank you. And the point here is, when we implement something as a pre-canned service, of course we are going to do all of the work that I just showed you for us and make the service really efficient and bring down the cost as much as possible. But the other valuable thing you save by using existing services is you save a lot of time and effort and headaches. You don't have to go through the headache of setting up Elasticsearch anymore. You just use the ready-to-use service. You don't have to go through the headache of setting up your own Hadoop cluster with your own Hadoop distribution. You don't have to set up your own transcoding stuff. You don't have to set up your own queuing system and whatever. So try to look through the, I admit, increasingly big portfolio of existing services and try to pick and match as many building blocks as you can that you don't have to reinvent anymore. And then you will not only save money, you will save a lot of time that you can put to much better use by reinventing the way you do business with your customers. Okay, before we wrap this up, let's take a quick look at cost monitoring and analysis. So you can use the AWS TCO Calculator if you are thinking about migrating a workload from on-premises into the cloud. This will help you come at a really apples-to-apples comparison about what it costs to run something on-premises versus what it costs to run in the cloud. It comes with a very detailed model of data center cost and that sort of thing, so you can create a nice cost projection for your manager and tell them how much money you can save by going into the cloud. You can also use the AWS Simple Monthly Calculator to project costs in advance for the future and try to figure out, so what can I save if I use reserved instances versus regular on-demand for this part here, and do some cost projections on your own for your existing architectures. You can use the AWS Billing Console to identify the first blocks to tackle in your cost optimization exercises. Just look for the biggest part of the pie and drill down and see where you can optimize that part further. Or you can use the AWS Cost Explorer to drill down more deeply into time-based trends in your data. You can watch either where costs go down, or you can watch out for costs that are trending up and then start optimizing before they become a more significant part of your bill. And then you can set up AWS Billing Alerts. Many customers I talk to, especially from the enterprise side, are a bit nervous because they are used to buying stuff, and then they know their costs, and then they know there's not going to be any more cost associated with that. And then they get really nervous if I come with a pay-per-use model that they find it hard to embrace. So you can set up AWS Billing Alerts, and we recently introduced budgeting support, so you can set up your own budget and make sure you're always within your budget, and you get alerts whenever you're starting to touch the upper levels of your budget. So they're a really useful tool, especially if you have to deal with your accounting department. So as a recap here, the easiest way to save money is to turn off unused instances. You can do it by hand, or you can automate the heck of your application and therefore be really smart about just using what you really need for your own particular use case. You can use reserved instances, and by paying up front, you can save a lot of money down the road, and the payoff here starts as early as 4 to 5 months. And Marcus showed you how you can bring down the EC2 bill about 50%. So that should save you a couple of trips to reinvent already. You can use spot instances and become more sophisticated about optimizing the cost out of EC2. You can leverage storage tiering so that you don't have to pay as much for storage for data that you don't plan to use that often. You can optimize for Amazon DynamoDB, and that helps us help Zed buy some new panels and repair his DJ setup. And then you can offload your architecture and save even more money there so that you can actually throw your own party with the money you saved on AWS today. So thank you very much for coming. Thanks. Thanks go to Markus.